In this talk, we will discuss the future of business process automation, example of an intelligent chatbot, what is structural equation modeling, what is genetic matching, and an example of genetic matching, and call for action at the end. So let's start by sharing an opinion of a machine learning pioneer who said stop calling everything AI. And I agree with him, because I think I saw people including very simple algorithms in the machine learning list. So I honestly believe that machine learning is more than an algorithm, like linear regression, for example. I want you to think a bit, how will a business process look like in the future? So for example, you could have a person who goes to a chatbot, right? So a chatbot then will ask the human to upload a PDF file. So that PDF file, for example, can be a sales document, and it's uploaded to the chatbot, and that triggers an OCR engine who reads the document and extracts, for example, the relevant information from there. And the OCR then will try to upload this documentation, this information, to SAP. So you can do that via API, you can do that via RPA, or either the backend or the front end could upload your data to the ERP system, to the SAP system. And then this part doesn't exist now in our business processes. Is the machine learning algorithm who could go back to the human and say, hey human, this is the decision you made, but based on the data, this could be improved in the future, right? Let's take a look at a chatbot that I find interesting.
Still feel so digital. Customers are tired of being frustrated by simple chatbots and dial-by-number menus. That's why Amelia is the most human AI. It's also the reason Amelia is the clear favorite among customers, analysts, and employees. But what exactly makes her so smart? Let's look at 6 secrets to Amelia's success. Amelia has deep contextual understanding.
Do I have enough money in my checking to cover upcoming bills? Otherwise, let's transfer enough to cover for my savings.
Amelia doesn't try to classify you into a simple task bucket. Her deep contextual understanding means she comprehends every part of a sentence, even when it involves multiple steps, conditions, and unexpected details.
You have $1,549 in upcoming expenses and $1,248.62 in your checking. Would you like me to schedule a transfer of $400 to safely cover the expenses?
Wait, what do I have in my savings?
Customers also demand flexibility. Your customers should be able to change topics at any time, just as they would with a human agent. This is where most chatbots fail. Amelia is able to context switch rapidly from one state to another, while still remembering which state she has to get back to.
You have $5,895 in your savings. Would you like to move $400 from your savings to cover the bills?
Can you make the transfer another day?
Sure. When would you like to schedule the transfer for?
Amelia is multi-threaded. Amelia's brain works like yours. As opposed to most chatbots, which are single-threaded decision tree systems, Amelia's brain is modeled after the human brain. When you speak to Amelia, multiple threads of Amelia's brain act in parallel to provide a rich response. You are not a single-threaded machine, so you should expect the experience of a multi-threaded cognitive system in response. Learning is key to your customers experiencing continually improving service.
I lost my credit card. Can I speak to an agent?
For something she's not trained on, Amelia mines embedded intelligence from all other transcripts to learn a course of action. She empirically augments her mind map as she learns from the agent, specifically assisting the customer regarding an unresolved problem. Fixed once by her human colleague, fixed forever thereafter by digital agent. Amelia has affective understanding. Digital agents showing empathy with the customers yield much better customer experience scores.
I'm exhausted. Can't wait for the weekend so I can watch some boxing.
Knowing when the customer is happy or sad and having the ability to respond with intelligence can dramatically improve customer satisfaction.
Sorry to hear you're so tired. Hopefully, we both can look forward to the next Tyson Fury bout.
Amelia leverages unsupervised analytics, noting which aspects of the service users are happy or unhappy with, and even providing insight into at-risk customers, helping increase customer retention. This might be a lot to take in, but the only part you need to remember is that Amelia is the most human AI. Because anyone you hire, human or digital, should deliver the same level of excellence you expect from your human employees. Are you getting the best from your digital assistant? Expect more from your conversational AI. Visit amelia.com today.
There are very smart chatbots out there. The technology is there. You just need to try it out. Next thing I want you to think about, and should we talk about, it's how could machine learning help you in your business process automation? One thing you could do is analyze latent variables influencing your business decisions. What is latent variable? A latent variable can be, if I can be borrowing a soccer or football example, so the latent variable could be how well your team defends. This is pretty obvious to the naked eye, but if you look at the data that is collected by football statisticians, like number of passes, number of tackles, number of yellow cards, balls recovered, and so on, any single variable cannot surely predict and be considered as the how well your team defends variable. No, how well your team defends variable can be a latent variable, which is a combination of number of passes, balls recovered, number of tackles. So that's something that you cannot observe directly, right? So you need to build it through a number of smaller unit variables, let's say. Another thing you could do is analyze which variables affect this latent variable. So do a linear regression on your latent variable, which is computed with structural equation modeling. I'll go in a minute in that. So in the end, hopefully your company will get more money because of having more insights on decisions, and customers will get to pay less because of better deals. And all this can be done via RPA platform, right? So that's where I want to get. Everything is available and everything is integrated with UiPath, for example. So let's talk about structural equation modeling. So what is structural equation modeling? You have your data and then you build a model which can look like this. How do you get to a model that looks like this? Well, first you should have a good theory, and second you should run exploratory factor analysis and confirmatory factor analysis. Running these algorithms, let's say, will give you the loading factors. For example, in this figure that you see on the screen, you have populist attitude measured by 3 populism variables and 4 anti-elitism variables, and these are the loading factors: 0.51, 0.64. In structural cohesion modeling, a good loading factor should be above 0.5, but preferably be around above 0.7. This is a model that I did in my first master's degree, where I studied political science, and I had an advanced statistical methods class for which I also wrote a paper. And in this is a model that I ran to see if authoritarian personality co-varies with populist attitude, and the answer was no, it's not statistically significant, as you can see. But then I found out that authoritarian personality is inverse or indirect, not direct but indirect proportionally, so it's a minus before, with authoritarian personality, and populist attitude has a 0.3 correlation with or regression on pluralism. Yeah. So then going back to business, so you could have any kind of data. For example, let's take data on your customers, right? So you have a number of variables that load on one latent variable, which can be the probability that your customer will default on the payment date, and not only one day, but they will pay 30 days later. So you could have 3 variables that load on your the probability to default on the payment date by 30 days, and then this latent variable you could run linear regressions on how many discount types what discount types you can give to your customers. All right, so then let's move to genetic matching. So what is genetic matching? With genetic matching you can simulate an experiment. So an algorithm that checks the probability that a unit with certain characteristics will be assigned to a treatment group. Okay, so we know from Western science, we know from science without Western, that the easiest and fastest way to conclude that something causes something else is through experiments, right? So if you Google correlation is not causation, you will find a lot of hilarious examples of why if you have a good correlation between 2 variables, let's say when you go shopping and when banks are robbed, there is no connection between these two, but for some periods of time, by pure coincidence, these two could correlate, right? And the police could, if they would be bad statisticians, they would only look at this and they would say, look, this because Adrian goes to shopping, banks are robbed, so Adrian is robbing banks. But in reality this is not true, right? So simulating experiments is very important, and genetic matching is an algorithm who can help you to simulate experiments. Moreover, it's better than an experiment because we can eliminate selection bias by balancing covariates between treated and control groups. So, machine learning in matching methods is something that is described on this slide. I won't go in details. Just I want you to know that this is considered as a machine learning algorithm because you know, as it's described here, as a method that incorporates some degree of algorithmic optimization or supervised learning, right? So genetic matching is not an unsupervised machine learning type of algorithm, because there are two types, right? Supervised and unsupervised algorithm. This is obviously the, let's say, dumber one, because it's unsupervised, right? It's not unsupervised. All right. So the next thing I want to mention to you is the Lalonde study. So how did this genetic matching, let's say, method come into the spotlight? Well, there was a paper wrote by Robert Lalonde in 1986 in a very highbrow academic journal, and this study was demonstrating how genetic matching beats linear regression. So the story is that the National Supported Work Demonstration ran a program to help disadvantaged workers lacking basic job skills moved into the labor market by giving them work experience, right? So the NSW program assigned qualified applicants to training positions randomly. And the Manpower Demonstration Research Corporation operated the NSW program in 10 sites across the United States. So they admitted into the program ex-drug addicts, ex-criminal offenders, high school dropouts of both sexes. And the program guaranteed a job for 9 to 18 months. So the results were pretty shocking. If you look at this table, in the treat 0, which means the group of study participants that were the control group, so they did not participate in the program, so they didn't have a job guaranteed for 9 to 18 months. And if you just look at their earnings, their mean earnings and even median earnings was higher for this group of people than for the group of people who participated in the study. This was very shocking. So did this mean that the control group had higher earnings than the treatment group? Yes, that's the reality, but how come? Does this mean the treatment had negative impact? Because if you just look at the mean or the median, this might be the conclusion. But with genetic matching, which simulates an experiment, the earnings seem to be higher, even for male and females, with around $800. So what happened here? Is this magic? No. Genetic matching matches your participants, so you don't compare apple with pear. So for example, imagine some teams are playing a sport. and you measure 3 variables: their budget in a certain year, how much their club values, and points they get in year 1 and year 2. Again, this is a football example. I used to love football, and I also wrote, this is a paper I wrote for the same advanced statistics class in my first master's degree. So I love this example. So you split this team playing a sport into 2 groups. One group that had an increase of 50% of their budget this year, and one group that did not. And you pair them according to your variables. So you pair club blue in terms of club value with club red, because they have similar levels of club value. Club yellow, you pair it with club red because they have similar budgets. And similarly, club yellow, you pair it with club blue because last year they had similar performance, right? So you don't look at averages of everyone, but you pair your participants, and then you have the unmatched, that simply there is not enough data, or they don't have a match in their level, right? And based on this pairing or matching, you calculate the probability that either blue, yellow, or red will be assigned to the treatment group, which is 50% increase in budget. Okay, so is this magic? Well, no, it's not magic, but you should always use genetic matching when you use linear regression. So the more variables you have to, the limitation of this method is that the more variables you have in your model, the less chances you have that your participants match on all your criteria. So there might be some variables for which you do not find pairs, and that might have effects on your results, right? So you need lots of data. So I took a real life example. I exported some data for my team in ADO, and I tried to apply genetic matching to my team enhancements, ticketing data, right? So I imagined the following experiment, that if I assign it to a particular person compared to an average of everyone else, will that increase the speed of delivery of the work? So I had variables like if it's a user story or an enhancement or just a ticket or an incident, if it's assigned to a particular developer, the size of the work, so measured estimated in story points, and the lead time. So I calculated how much assigning a work item to a particular developer leads to increase or decrease in lead time. If you are curious about the code of this model, you can go to this video. I won't go now through the code. I'll go to the results. So assigning it to a senior developer might be for you a sign that the work will be developed faster, and to a junior that it might be developed slower. But if you look at the lead times, this might be true or not. In this case, not. But this is misleading. Why? Because you look at lead times for every size of an enhancement, for example. So you should look at the lead times for every size and every type of work. This is more categories to take into consideration, but genetic matching will do that for you. So in this case, if I run genetic matching, I see that my junior developer will do it 40 days faster than my senior the average of everyone else. So that minus there says it's faster. But this data was not statistically significant, so there's not enough data to run your models. So you should be careful, have enough data. Not like for my team, we didn't have enough data, so please take these results with a grain of salt. And you would say, so what? So imagine if we applied this method of machine learning to every agile team in every IT company. We wouldn't need planning anymore. Why? Because the algorithm will tell us who is to be assigned to a card based on its characteristics, like size, for example. So why is this important? We could start implementing it in current RPA platform. So UiPath has integration to RStudio. RStudio is free, open source. We just need to convince IT security to let us install RStudio because it's there, ready for us to use. And with RStudio, I can calculate any kind of machine learning or other types of data insights that I want. So ideally, how will a new process look like? Well, a business chats the chatbot and uploads a PDF file, as I mentioned in my first slide. And 30 minutes later, a robot will text to speech to the business who uploaded that PDF file the following. And imagine me talking with a robotized voice. I see that you have given this client discount type X. Based on the data, they have 3% chances of default on the payment date with 30 days, and that a better discount would have been discount type Y. Based on their company type and historical data, that discount type would have resulted in just 1% default rate on their payments date. But anyway, great job, sales guy. So this is how a new process will look like in the future. And you know what, guys? We have tons of processes in our companies. Our teams should have periods of evaluation of the flows to recommend similar exercises to which I have imagined here to any kind of process. But not only. Also, we can invent these new processes. Imagine applying these new technologies across functions, departments. So far, we have applied automation by cherry-picking some low-hanging fruits within departments. However, the real benefits in the transformation of our organization. And transformation, a real transformation, will only come by applying a combination of computer vision, machine learning, automated scripts execution, and natural language processing capabilities across functions, and most important, across levels. So also up and down. So, it came to call to action. Practice everyday data science skills. Anything starting from regression to advanced methods will do. I suggest you start reading any book that is introductory to statistics. Collect as many data as possible. I have started with Amazon data in 2017, for example. I was just data scraping with UiPath the prices of things, of books. And then I data scraped flats. You know, there are databases with flat prices, and I analyze the trends in the prices. Play with the data. Imagine what you could do with that data. Write to me, to the world, this is what I did with the data. Sharing is going to improve your understanding of how you see that data. This is the only way we will invent the new processes. So have fun. And don't forget to fill in the survey and check my latest book trailer.